Okay, review number 2. Once again, we're going through some reviews as part of the requirements to earn college algebra credit through UMSL. Here we go. All right, we're going to be looking at systems today. So solving systems just means we're looking at two linear equations and wondering, hey, if we graph them, where are they going to intersect? But instead of graphing them, we're focusing today on solving them algebraically. So what you want to do in this case is you want to use substitution. If you want to find out where these two lines overlap, and you see that y equals 2x minus 4, and y also equals, in this system, 3x minus 5, then what you're going to do is say, hey, when I see y up here, I'm going to plug in what y is equal to, 3x minus 5. You may have learned this in Algebra 1. Your teacher may have just taught you that, hey, if y equals, okay, drop the eraser. If y equals 2x minus 4 and y equals 3x minus 5, then 2x minus 4 equals 3x minus 5. Either way, it's the same thing. And now we've put those two linear equations together to make a system, and we're going to solve them together. So we'll go ahead and subtract 2x from both sides. That gives us x. We're going to go ahead and add 5 to both sides. 5 minus 4 gives me 1. We're halfway there. Once again, remember, when you're doing a system, that means you're going to end up with the answer of a point. So we've got our x value for our point. Now what are we going to do? We're going to pick either equation. The top one looks a little bit easier. Not really. I mean, they look about the same. And we're going to say, all right, in this system, when x equals 1, what does y equal? And so it's going to be interesting because your answer, let's see what your answer is. 2 minus 4 is negative 2. Your answer is the same no matter which equation you would have put it in, right? If we would have put that 1 in there, 3 minus 5 is also negative 2. So we found the point that works for both equations, and that is 1 comma negative 2. Let's see what's behind this orange blob. All right, there we go. We can solve by using substitution, which we just did there, or we can use elimination. And so once again, I'm going through this pretty quickly because this is Algebra 1, and hopefully this is all you need to kind of shake things up. If you need more, I've got my Algebra 1 blog that has those videos. Just request them and I'll send them your way. All right, so here we go. We've got something now that looks like it's best set for elimination. Substitution we're usually going to use when one of the variables is already isolated, like it was in the last problem, y equals something. So here I did the steps. These are from my algebra steps, and it says, are they both arranged in standard form? Yes, they are. Standard form is, right, ax plus by equals c. And then step 2 is we're going to pick either the x or y and try to eliminate one of them. This is set up super easy so we can remind ourselves what elimination is all about. If we add these two equations together, look what's going to happen. 5x plus 4x is 9x. 3y minus 3y, whoa, gone, eliminated, right? Hence the name. Bring down the equal sign. 16 plus 2 is 18. And we keep going, dividing both sides by 9. We get x is 2. Remembering that in a system, our answer is going to be a coordinate point. And so here we go. We can pick either one. I always like to gravitate towards the equations rather they don't have a negative, just so we don't get messed up with negatives. And we're just going to plug in at 2 because now we know x is equal to 2. We're almost there. Let's go ahead and solve the equation. 5 times 2 is 10. If we subtract 10 from both sides, we get 6 on the right side, divide both sides by 3, and we get 2. So 2, 2, oh, that's my favorite answer. What does a ballerina wear? A tutu. Yeah? Okay, if you didn't like it, you just have to get used to that because I do corny jokes every now and then. I can't help it. All right, so here we go. 2, 2, if you plug them back into both equations, they'd work. So we have solved this system of two equations. Let's try another one. This one, oh, yucky. They're not both in standard form. So that's the first thing that we're going to do. Let's switch it up. Let's get a hot pink. I always love, or kind of like a magenta. That sounds good. Let's go ahead and take that first equation and bring that 5x to their side. We're going to do that by subtracting 5x from both sides, right? So it's gone from the right side and it appears on the left side. Now we have both equations in standard form. So that would be the first thing you're going to have to do sometimes. Now when I look at it, it's like, oh, bummer. I just can't add them like I did the last problem and have things cancel out. But, so, okay. if we're going to stick with the steps, I would be looking right now at step 3, make a wish. Oh, okay, I'm going to make a wish for you. I wish, because I can't hear you through my video, right? I wish that this 7 were a negative 14. That would make my life so much easier. All right, well, it would make this moment so much easier. Maybe not my life. And so how do I turn 7 into a negative 14? Now remember, what I do is I either have to multiply it by a number to get negative 14 or divide a number. I can never do addition or subtraction. So I'm going to go ahead and multiply it by negative 2. And you're like, wait a second, Miss Overby. You can't just go ahead and, so if you can see, I'm now taking this and I'm bringing down here. And you're like, wait a second. You're breaking some rules here. You just can't go ahead and multiply that 7y by negative 2. I sure can, as long as I go ahead and multiply every term in this equation by negative 2. Then I keep the integrity of the equation intact. So negative 5 times negative 2, right, is going to give me a 10x. And then I already did the 7y times negative 2 to get the negative 14. And let's not forget, because sometimes students do, we have to multiply that last number on the right side also by negative 2. So 12 times negative 2 is negative 24. Finally, we have set up within this right here, we've set up a system that we can go ahead and solve. So here we go. 8x plus 10x is 18x, and we're just kind of repeating ourselves. Eliminate, that's awesome. Negative 24 plus 6 is negative 18, right? We're going to divide both sides by 18, and the rest of it's pretty much history, right? We know x is equal to negative 1. We've got plenty of room over here. Let's go ahead and plug in, let's use this one, right? We'll plug in negative 1 for x. So we're going to plug that in, and we're going to solve for y. So that's negative 8. Probably shouldn't have written that step. No time. Plus 8 plus 8. So we have 14y equals 14. Divide both sides. Y equals 1. And that point, my dear students, works if you plug them both in. If you plug them into both equations, you'll get a true equation. All right. So let's try another one. Let's look at number 4. So this looks like great. We're in standard form. But not so great because when we make a wish, it's not going to work. There's nothing I can multiply 2 by to turn it into a 3. There's nothing I can multiply 4 by to turn it into a negative 5. So making a wish once is not going to work. We have to make a wish twice. So this is how it works. We're either going to focus on the 2x and the 3x or the negative 5y and the 4y. Since that 5y already has that negative in place, I'm going to focus on the negative 5y and the 4y, and I'm going to say, you know what, let's turn them both into 20s. So then we'll have a negative 20 on the top and a positive 20 on the bottom. So here we go. Let's focus on the top first. If we are going to change negative 5 into a negative 20, we're going to multiply by 4, right? So that means we have to multiply every term by 4. So here we go. We've got 8x minus 20y equals a negative 24. We're done with the first one. Let's look at the second one. If we want to change this 4y into a positive 20y, we have to multiply by 5. So we're having to make a wish 2 times, and we're going to have to do all this hard work. 3x times 5 is 15x, 4y times 5 is 20y, and 14 times 5, oh no, let's see, that's 50 plus 20, that's 70. Don't have my calculator with me. I came up to school to do this. It's really nice to be back in school. I can't wait till we all can be in person again when it's safe to do so. All right, so let's go ahead and start adding. 8x plus 15x is 23, right? 23x. This one's gone. Those are eliminated. 70 minus 24. Oh, this is awful. 10 minus 4 is 6, and 6 minus 2 is 4. 46. Yay. And when we divide both sides by 23, we get x is equal to 2. I'm going to stop here because we already know how to do it. We plug the 2 in and we get whatever that is. That's not the important part. All right, hopefully this review is helping your brain's pathways to kind of wake up, because this information, because you've done it in Algebra 1, you've done it in Algebra 2, it's stored in your brain and your long-term memory. It's just those pathways that aren't really strong because you haven't used it in a while. So that's what this video is about, awakening your pathways to the information. I believe this is our last one. Yay, it's our last one. All right. Do you notice something particular about this system? I do. So, right, if we went ahead and changed this negative 3x into a negative 9x, we'd be multiplying by 3, right? Well, if I did that, it'd be like, great, I only have to make one wish. But as I do that, look what's going to happen when I multiply the rest of the terms by 3. I'd end up with negative 6y, and then 30 times 3 is equal to 90. And I'm like, wait a minute. If I bring this first equation over, I'm going to have my variables cancel out, right? And so when the variables cancel out, you know, we're used to saying 9x minus 9x. It's gone, right? 6y minus 6y, it's gone. But when something's gone and there's nothing left, what number do we use for nothing? That's right, we use 0. And so 0 equals, 90 minus 20 is 70, so that must be 72. Is that true? When the variables are gone in a system, when you're solving a system, and you're left with two numbers, you have two choices. You ask yourself, is this true? Does 0 equal 72? Not in this world, right? So we're going to say no, and that's the first part of your answer, right? It's no solution. Now, if you're wondering, and I'm going to do this so that we see that I'm talking about something completely different. If you're wondering what would happen if we solved the system and we got something like 0 equals 0, well, is that true? Yes, and what that indicates is that no matter what x and y's you plug in, those systems are basically the same equation. It's the same equation, so any number is going to work. A better way of saying it is, if it's true, you just say there are infinite amount of solutions, right? So infinite solutions. All right, thanks for joining me. I look forward to probably seeing you in Zoom, or if this is past the pandemic, I will see you in class. Thanks for joining me.